In this video, we will explore word clouds, a visual representation of textual data, and try implementing it through coding. A word cloud is a visual representation of text, where words are displayed in varying sizes based on their frequency in the text. Through word clouds, we can quickly gain quick insights into the most common terms in a document, making them valuable for summarizing textual data. In a word cloud, the most frequently occurring words are usually depicted as larger and bolder, while less common words are smaller and less prominent. However, it's important to note that word clouds do not provide information about the context or relationships between words. As mentioned earlier, word clouds offer a quick and visually appealing way to understand the most important words and themes in a given text. Therefore, word clouds are utilized for various purposes. Firstly, they can be employed for analyzing survey responses or summarizing documents. Additionally, they find applications in social media, sentiment analysis, consumer reviews, and feedback analysis. Furthermore, word clouds can be used in brainstorming and idea generation. To create a word cloud, text pre-processing is necessary. Text pre-processing involves tasks such as tokenization, removing special characters, and eliminating stop words. Referring to the previous video on text pre-processing may be helpful in understanding these steps. After text pre-processing, the next steps involve counting the frequency of the generated words and visualizing them by adjusting the font size based on their frequency. Now let's code the process of creating a word cloud using an English text file. The Jupyter Notebook file is available on GitHub, so you can download it and execute it yourself. Firstly, we'll load the text file and store it in the doc variable. After this step, the doc variable will contain English text data in this manner. Next, we'll perform the text pre-processing steps. As explained in the previous text pre-processing video, we'll utilize the text pre-processing library provided by NLTK. In this case, we'll remove anything other than alphabets and extract only words with 3 or more characters. Then, we'll convert all the words to lowercase using the lower command and store them in the data2 variable. Printing data2 will reveal words consisting of lowercase alphabets with 3 or more characters. After that, we'll use the stopwords library provided by NLTK to remove stopwords. By using a for command, the words that do not belong to the stopwords category are stored in the words variable. This step will result in the removal of words like are, most, the, they, etc., as shown in the printed output. However, upon examining the obtained results, we may find that unnecessary words are still included. Depending on the purposes of text analysis, an additional step of removing more stop words may be undertaken. In this case, words like based, high, however, among, etc. persist even after the initial stop word removal. To address this, a new list of stop words can be created, including the words to be removed. Subsequently, we count the frequency of the obtained words. In this example, the word wheat appears 25 times, maize twice, and rice 3 times. After counting the frequencies, we extract the top 20 words based on their occurrences and store them in the top 20 variable. Of course, you can adjust the number, for instance, changing it to 50 to extract the top 50 words by frequency. Next, we import the word cloud library and the matplotlib library for drawing graphs. After that, we generate a word cloud for the top 20 words stored in the top 20 variable, which we obtained based on their frequency. The word cloud is created like this. So we can observe that words with the highest frequencies, such as wheat, bread, volume, etc., are prominently displayed in the word cloud. Of course, you can adjust these parameters in order to control the size of the word cloud, background color, and font size, etc.